Today in class we looked at standard form graphing. So graphing our linear equations from standard form. Oh, I have my keyboard unplugged. All right. So standard form is ax plus by is equal to c. And the problem with standard form, nothing about this form is the points. We don't get a slope. We don't get an intercept. We basically get nothing from it. All we know about this form is that it is linear, that it's a straight line. So what we're going to do is we're going to find x and y intercepts in order to graph this. So if I've got my standard form 3x plus 2y is equal to 6, to graph it, I'm going to make a table of values. And so I'm going to plug 0 in for x, and I'm going to see what I get out for y. So I plug 0 in for x. Three times 0 is 0. And 0 plus 2y is just 2y. So all of this stuff basically disappears. I divide both sides by 2. And it turns out that when x is 0, y is 3. Now I have my y-intercept, and I can plot that point. In order to graph any line, I need 2 points, so I need to do this process again. I could plug in 1, I could plug in 2, I could plug in 3, I could plug in any number I want for x, but actually the easiest thing to do is to plug 0 in again, but this time in for the letter y. So I take that same equation, 3x plus 2y equals 6, but this time I'm going to plug 0 in for y. That gives me 3x plus 0 equals 6. So really it's just 3x equals 6. All this stuff has disappeared. I divide both sides by 3, and x equals 2. Now I have 2 points that I can plot to find my line. One fatal flaw about standard form is a lot of the time your x and y intercepts aren't going to be perfect whole numbers. So maybe I have 2x minus 5y is equal to 9, let's say. I'm still going to approach it using our newest technique where I'm going to plug 0 in for x and for y. When I plug 0 in for x, I get 2 times 0 minus 5y equals 9. So that 0 causes this to disappear, and all I have is our negative 5y equals 9. I divide by negative 5 on both sides. And this is where I'm going to use a calculator to get a decimal approximation for me. So 9 divided by 5, I get 1.8. I'm just going to make sure that I include our negative. So y is negative 1.8. I'm going to do the same thing, but for y equals 0. Excuse me. So I get 2x minus 5 times 0 is equal to 9. That 0 causes all this stuff to disappear, so all I have is 2x equals 9. I divide both sides by 2, and I get 4.5. I'm then able to plot those points. Excuse me, I'm sorry. I'm able to plot those points to get my line. So what I want to practice here is just plotting some of these points. So I'm going to use my colors instead of black ink here. So let's start with red. If I want to plot the point 0, 5, that's 0 on the x-axis, 5 on the y-axis. That goes right here. 0 on the x-axis, which is this one, 5 on the y-axis. If I want to plot the point -2, 0, well, that's -2 on the y-axis, 0 on the y, so -2, and then 0. If I have one of those decimals, let's say I have 1.8 equals 0, so I'm going to make it a positive instead of a negative. So 1.8 on the x-axis, so here's 1. It's not quite 2. Got $1.80. It's going to be right about there. And then last but not least, maybe I've got 0, -3.1. If I have that, it's going to be slightly beyond -3. So 0 on the x-axis, but 1, 2, 3, and 3.1 right there. All right, so let's graph some of these standard forms. Maybe we've got 4x minus 2y equal to 8. All right, so I've got my table here. So what happens is with the 0 going in for this x, that part of the equation gets taken care of. So I have -2y equal to 8. I divide both sides by a -2. And y equals -4. Plugging 0 in for y causes this part of the graph, or this part of the equation, to disappear, and I'm left with 4x equals 8. I divide both sides by 4, and x is 2. I'm going to plot these 2 points, and then using a straight edge, I'm going to connect them. So starting with our 2, 0, that's right here. And then 0, -4, that's right here. There's our two dots. All we have to do is connect them with a nice line. And we have graphed standard form. Let's practice another one. Let's throw some more negatives in there. Let's go -x minus 5y. Oh man, got a catch there. Is equal to 5. All right, so I got 0. I'm going to plug 0 in again. 0 for x causes this to go away. So I have -5y equals 5. We divide both sides by that -5. So y is -1. Plugging 0 in for y causes that to disappear, leaving us just -x equals 5. I don't want -x. I need it to be a positive x. So technically this is a -1x. We're going to divide both sides by a -1 to make it be a -5. Plotting these 2 points, the -5, 0 lands us here. 0, -1 lands us here. Now that we have 2 dots, we can graph our line. I'm going to adjust it so it's actually accurate. And there's our line. Last one, looking at those decimals again. Let's say the one like number 10 on our homework. Let's say I've got 2x minus 4y equals 1. Going to make our table 0 and 0. So 0 goes in for x. I'm left with -4y equals 1. Divide by -4. and y is negative 0.25 as a decimal. Plugging 0 in for y gives us 2x equals 1. We divide by 2, and x equals 0.5. We plot these 2 points, so the 0.5 I'm going to do here in purple. 0.50 is right here. Negative 2.0 is right here. And this is where the importance of your ruler cannot be overstated. When the dots are this close, you can draw a perfectly straight line through those two dots, and it is the exact line you need for this equation. But if you try to do it without using a ruler, it's not going to look good. So I'm going to draw a rough sketch of it. Now, since I'm on the computer, I can adjust it. You're going to try your best to go through your two estimated points. And there's your line. If we try to freehand a line, especially when the dots are this close, we might be perfect like right here. We might be like, yeah, look at that. But then drawing it the other way, we're not going to have a very good line. So we always want to use a ruler when you're drawing lines. That's standard form.